Morning, everyone. Welcome to the Swetland Seminar Series. We're excited for you all to join us today. My name's Linnea. I'm a project manager here at the Swetland Center for Environmental Health. And if you'd like, let us know where you're joining from. Share your name and your organization, maybe your location in the chat box. So if you're not familiar with the Swetland Center, the late 1950s, David W. Swetland and Mary Ann Swetland felt not enough was understood about the unintended health consequences of chemical, agricultural, and industrial products in our environment. So they focused the Mary Ann Swetland Professorship of Environmental Health Sciences on preventative medicine and the threats of man-made environmental hazards, so that all graduating doctors would have an interest in and understanding of the impact of the environment on human health. So today, the Swetland Center continues Mary Ann Swetland's legacy by building partnerships to find and scale solutions to redress the environment's disparate impact on low-resource populations in Cleveland and beyond. And as research continues to demonstrate the vital connection between the environment and health, our center is positioned to respond. And our mission is to study the complex interplay between environmental determinants and population health outcomes. We place special emphasis on community-engaged approaches that address the role of structural racism in creating and sustaining environmental health inequities. And we seek to translate these findings into policies, practices, and relationships that promote community and population health equity. And if you're interested in learning more about the Swetland Center, you can check out our website at case.edu/Swetland, scan this QR code. You can email us, swetlandcenter@case.edu. And we also encourage people to sign up for our Swetland Scoop newsletter to keep up to date with what we're doing. It comes out every 2 months usually, and we'll always be posting updates about when the next Swetland seminar is. So anybody that joins our Swetland seminars will automatically be added to the list that just gets notifications about the next seminar. So you'll be up to date on those. Speaking of which, our next Swetland seminar is next month, Tuesday, April 15th, Harnessing the Power of Constructive Conflict Among Community Institutional Partnerships. And it's in person only on Tuesday the 15th from 9 to 11 a.m. at our new office in the Carew Institute for Population Community Health at Midtown Collaboration Center. So join Michael Walton and Dr. Darcy Friedman for an engaging workshop to identify how conflict can be productive to innovate solutions through community institutional partnerships. Attendees will also learn how to apply tools for preventing and treating destructive conflict in community institutional partnerships and identify core features of relationship building and conflict management approach relevant for unique projects among workshop participants. We encourage you to participate with your team. We do have several spots left. I believe registration closes April 11th, I want to say, a few days before the workshop. We will have coffee, fruit, and pastries, like a light breakfast provided. So you can either scan that QR code or we'll put the link in the chat as well if you want to register for that next seminar. And we will have more details coming in the next few months. But if you want to save the date, the next Swetland seminars for the rest of the year are September 16th and November 18th at our usual time, Tuesday from 9 to 10 a.m. And those will both be virtual as well. Okay, so now I will turn it over to our director of the Swetland Center, Dr. Darcy Friedman, to introduce today's speaker.
Well, thank you, Linnea, and welcome everybody to our seminar today. I'm very excited to have the opportunity for all of you to hear from Dr. Myron Lard. He earned his Bachelor of Science in Chemistry from Kent State University and his PhD in Analytic Environmental Chemistry from Louisiana State University. Dr. Lard is a postdoctoral scholar working in the Department of Forestry and Environmental Resources at North Carolina State University. He earned his PhD supported by the NIEHS Fellowship, like I said, at LSU, where he worked as a member of the Superfund Research Center to study combustion-related toxicants. In his role as a postdoc, he will be working to study the impacts of open burn waste treatment on a small community in northwestern Louisiana. I had the opportunity to meet Dr. Laird through some of the work we were doing with the center within the East Palestine community following the train derailment. And it was such a pleasure to get to know him and learn about his research. And I'm excited for him to share more today. So welcome, Myron.
Thank you for that glowing introduction. I'm really excited to talk to you guys today and share with you what I've been working on. So let's see. Can you all see my slides? Great. Still just the slides?
Yes, yeah.
Okay. So like Darcy said, my name is Myron, and I am currently a postdoc at NC State. And today I'm going to talk to you a little bit about my research where I have worked to analyze soil contamination after major combustion events. So just a quick about me, Darcy covered most of this. I did get my bachelor's degree from Kent State in 2020. While I was there, I did some undergraduate research at Gojo Industries. I got my PhD in analytical environmental chemistry from LSU in December of 2024, so I'm a recent doctorate. And while I was there, I was able to, I was awarded an NIEHS research grant so that I could just focus on my research and allowed me to partake in some really exciting extra research opportunities that I wouldn't have been able to focus on without that funding. And now I am a postdoc at NC State, and I'm working with the residents of Colfax, which I'll talk to you guys a little bit about today. And we are working on studying the impacts of these open burn practices. So today, I'm going to break my presentation up into three parts. We'll start with an introduction into combustion byproducts and where we did our sampling. And then I'll talk to you about those results. And then I'll talk a little bit about how we use these samples to further the understanding around these combustion byproducts. So to start, we'll just talk about combustion. So combustion is a very common practice that is used for the treatment or disposal of waste that is commonly used in industry, but it's also used in household practice, you know, if you have a burn barrel in your backyard. So it is a very time and cost efficient method to disposal of this waste. When you compare it to other remediation methods like chemical remediation, they can be very costly. So burning things is the most efficient and the most time and cost efficient way to get rid of waste most of the times. But the problem with combustion is that it generates several byproducts that are definitely connected to serious health impacts. Dioxins, PAHs, PFAS, things that you are very familiar with as combustion byproducts. Today we're going to be talking about dioxins, which I'm sure you've heard of, and then we're also going to be talking about a class of combustion byproducts that you might not be familiar with, which are called environmentally persistent free radicals. The problem with large-scale combustion is that it has widespread impact. Emissions like smoke can't be controlled, so when they go up, they are just dispersed outward into the surrounding communities, and they can have serious negative impacts. So let's talk about the two key classes of combustion byproducts we're going to talk about in this presentation. Starting with dioxins and furans. These are highly toxic environmental pollutants that are commonly formed through combustion processes, which have been directly attributed to developmental issues, cancers, and thyroid disease. Industrial sources of these pollutants include waste incineration, smelting, and herbicide production, but we're mostly focused on the waste incineration here in this presentation. Biological danger of these dioxins and furans are reported using the toxic equivalency value, which is used to determine the baseline levels for response. These values are determined by US EPA, and they are determined, or they are referenced using the regional screening level, which corresponds to a 1 in 1 million risk for the given health outcome if exposed to the pollutant for 30 years. So for dioxins and furans, the regional screening levels for cancer and non-cancer risk are 4.8 picograms per gram and 51 picograms per gram, respectively. The way we did our dioxin and furan analysis is by collecting the soil samples and then using high-resolution gas chromatography and mass spectrometry. We used the EPA standard method 8290A, and we measured for a total of 17 dioxin furan congeners. I have those at the end of the presentation if anyone is interested in the 17 that we measured. And then, like I mentioned before, we took the concentrations of each congener and we calculated the TEQ. The TEQ value is generated using this formula, where we take the concentration of each congener and we multiply it by that congener's toxic equivalency factor, which relates the toxicity back to the most toxic dioxin, which is TCDD. So this toxic equivalency factor is multiplied by the concentration, and then all the summation of all of these for each sample. So all the congeners in each sample are added up, and then you have a total toxic equivalency value. And now we'll talk about environmentally persistent free radicals. These are free radicals that are typically generated through combustion processes like cigarette smoke and wildfires. But they're also generated through industrial processes when soil and airborne particulates interact with the waste streams that are generated through thermal remediation. These typically happen when aromatic compounds react with the metal present, generating a stable radical that has been identified as a potential toxicant in the health, and it has significant health effects. So here is just a general schematic of the formation of one of these environmentally persistent free radicals. We see the organic compound or the aromatic compound here that interacts with the metal center in the soil. We have our chemical reaction eliminating a water, and we form this complex. Then an electron transfer happens, resulting in our stable free radical that can be stabilized through resonance with this aromatic ring. So the radical stability is very high in environmental conditions due to that resonance. So this long lifetime of up to years increases the potential for negative health impacts via inhalation and negative interaction inside the body. And evidence suggests that these radicals pose significant health risks. They are directly connected to pulmonary and cardiovascular ailments, and they have been found to participate in additional radical reactions, generating reactive oxygen species and also recombining to form these toxic dioxins and furans that we're also focused on. The way we analyze for these environmentally persistent free radicals is by using electron paramagnetic resonance, which allows for the detection of unpaired electrons. So this is really useful in detecting free radical species. So when we measured all of the samples, all of the soil samples that we've tested in this presentation generated these very complex multi-radical signals. And so we were able to use a deconvolution, which is actually the first validated methodology that has been published for identifying the individual peaks of these complex signals. So when we do our deconvolution, it provides information about each of the radical signals in the complex signal. And so we can use this deconvolution to determine radical concentration and identity by pulling out these pieces that we normally wouldn't be able to see. So the two key sites that we focused on in this research, I'm going to talk to you first about East Palestine, the site of the train derailment that happened in February of 2023, where approximately 50 cars derailed, spilling the contents. Vinyl chloride, butyl acrylate, and isobutylene were among the chemicals that spilled. And then 3 days after the derailment, there was a decision made to do a vented burn of the remaining cars filled with vinyl chloride. And as you can see in this image, there were two very large fires and very significant smoke plumes that traveled outward from this combustion. So we wanted to determine what kinds of impact this had on the surrounding area. In addition to East Palestine, I'm going to talk to you about Clean Harbors Colfax, which is the focus of our research currently ongoing in northwestern Louisiana. So Colfax is a very small town, which is predominantly composed of low-income minority individuals, and it is also home to Clean Harbors Colfax, which is the only commercially operated open burn and open detonation waste treatment facility in the United States. They are responsible for the disposal of military waste, fireworks, propellants, and even soils excavated from Superfund sites. So they are responsible for the disposal of some very, very nasty things. And what they do is they load these nasty things onto these burn pits, which are out in their facilities, out in their facilities land, and they load the waste onto these burn pits, and they just open burn it, and they allow the waste streams to go wherever they go. Uh, Clean Harbors consists of 20 square burn pads, and they have 10 storage magazines with up to 50,000 pounds of storage capacity. So they can store a lot of really dangerous waste, as well as working to dispose a lot of waste at the same time. So now that I've given you some introduction, we can talk a little bit about the results of some of our studies. So the reason we got involved in East Palestine in the first place, during my graduate studies, I was part of the LSU Superfund Research Center, which studies environmentally persistent free radicals, which, as I mentioned, are like contaminants that are typically generated through combustion processes. So a couple months after the derailment, I came to Kent State to present my research, some of the research work that we had been doing in Colfax. And while I was in Kent State presenting our Colfax research, I spoke with some researchers at Kent who suggested that we potentially use some of our expertise to help the community in East Palestine as well, because EPFRs are not a very commonly studied contaminant. And so we have a very localized expertise that can come in and do some studies that not everyone can carry out. And so we also knew that the derailment and the vented burn created conditions that were conducive to the formation of these byproducts, right? So we knew that the conditions that happened when they burned these chemicals were likely to have generated some of these byproducts. So we wanted to come in and make sure that we were doing independent testing and identify the presence of some of these combustion byproducts. So we tested our soil samples for dioxins and furans, and we also tested for EPFRs. We tested a total of 37 total samples in East Palestine for EPFRs and dioxin furans. We took 27 sample locations, both residential and public property, which were collected in and around East Palestine, both in the community and in the surrounding township. And then we also took 10 samples that were collected from a Columbiana farm as a sample-specific background. We collected samples from 0 to 6 inches in depth, and six of our 27 samples were actually collected by EPA. They were collected from the area directly around the derailment, and so we were not personally allowed in, and we refer to those 6 sites as the restricted area sites. So this research has actually been recently published in Environmental Science Processes and Impacts. This is the manuscript title. We were actually just published maybe a little over a month ago now. And so I actually do have a QR code at the end of the presentation to access this, so you don't need to scribble down the title really quickly. But I just wanted to let you know that this work that I'm going to be talking about coming up has been published. So here is our sample map. These 2 X's indicate the site of the derailment. You can see that we collected a number of samples from inside the derailment area. These 6 indicated by the little guys are from the restricted area. And then you see that we collected a decent number of samples throughout the town. And then we also collected outside of town for comparison purposes. So when we look at the results, we can see that we have some elevated levels of, these are our dioxin and furan TEQ values. So we look at the derailment area, or the restricted area, as we refer to it. We can see that all of our samples collected in the restricted area were at least in this yellow category, and our highest value was actually in the restricted zone as well. So these yellow values are values that returned above the cancer regional screening level of 4.8, but below the non-cancer of 51. Red values are above the non-cancer of 51. And then blue values are below the cancer regional screening level. So as you can see, all of our values inside the restricted area returned above the cancer regional screening level, indicating that there is a sufficient risk over 30 years. So when we compare our values, here is our LSU sampling set. When we compare it to the values collected by EPA and Norfolk Southern, we see a kind of similar spread. We notice that our values above the cancer regional screening level and non-cancer regional screening levels are consistent with the values measured by Norfolk Southern and EPA. In our data set, we had values ranging from 0.8 picograms per gram, which is well below the non-cancer threshold or the cancer threshold. And we also had values up to 88.2, which is well above the non-cancer threshold. So 48% of our measured samples actually return values above the cancer regional screening level, suggesting that there is an ongoing risk and that additional work needs to be done, even potentially additional remediation should be looked into. And then when we look at our EPFR concentrations, we again see our most elevated values are up in our restricted area, which is again consistent with the burn practices being responsible for generating these elevated levels. As we were looking into the plume, the deposition plume, it is actually modeled to have traveled directly over these two sites, which were our highest two concentrations of EPFRs, and also were higher in concentration in our dioxin values as well. So as you can see, we identified elevated levels of both contaminants in the East Palestine sample set, especially values in close proximity to the derailment area. So moving forward with our East Palestine studies, we want to do a more widespread study sampling set. We only were able to collect 27 samples from the community at this point, but we would like to do a more directed and more comprehensive sampling that allows us to not only study the deposition plume, but study inside this area here. So this image is the evacuation area of the immediate evacuation area after the burn. So this is what the governor released after the derailment incident. And we want to study inside this, and also we want to study the entire modeled vented burn by IMAAC. And so when we study these deposition plumes, we'll be able to more closely identify if the relationship between the derailment practices and these persistent toxicants. Because right now we are only able to just suggest the connection, but because we have no background sampling, we didn't do any sampling in East Palestine prior to the derailment because no one expected the derailment to happen. There was no background sampling to compare to. So if we were able to do a widespread and very direct sampling set, we would be able to compare areas outside of the plume to areas thought to be directly influenced by the plume. And this would provide us with critical information about the relationship between the vented burn and the presence of these combustion byproducts. So that is our East Palestine studies, and now we can switch over and talk a little bit about Colfax. So to understand Colfax, we need to go back a little bit. The Colfax project started at LSU before my graduate studies began, and during peak COVID is when the LSU team wanted to initiate this study. So there was a lot of virtual connection between LSU and the community members, where we obtained a lot of community testimony, public comments from public hearings, and we reviewed all of those to obtain information about how the facility, how Clean Harbors was affecting the community members. The community members described numerous issues, including health issues, noise and vibration, damage to their homes, death of animals, some very serious things that you don't want to happen due to a facility that is just burning in your backyard. And of course, the facility consists that all of their emissions produced are contained within the facility walls, but the facility wall is a chest-high chain link fence, so you can imagine how much of the emissions are actually being stopped by that. And so we took the oral history that we gathered and we quality assured it and we coded it and put it into maps so that we could visualize a little bit how the facility was impacting the community. So here are a couple of those maps. And so the red crosshair on the map is the facility. And you can see that the residents that have issues are labeled, are the red. And so the hotspots are obviously directly around the facility. And you can see that even though it's not directly around the facility, we do have some residents reporting some issues outside even further. So we took these community testimonies and we took some meteorological data, and we were able to generate emissions models of how the smoke plumes were actually generated from the facility and how they were dispersing throughout the community. And as you can see, every ring on this is 3 miles away from the facility, and our modeled pollution plume has very, very significant pollution effects going out some 15 miles into the community, which is a lot further than what the facility says, as it is definitely not just contained within their walls. This modeling is also consistent with community testimony that I just showed, the pollution plume traveling primarily to the southeast, which is the direction that we saw a majority of the community testimony complaints of these issues happening to them. So we decided to set up a sampling after we were sure that the community testimony and everything lined up with emissions from the facility, and that we would be able to help the community solve this problem that they were facing. So we set up air and soil sampling from several sites, varying distances from the facility. We did sampling sites directly south and east of the facility, and we did one simple site that is far away from the facility. The air samples were collected using passive samplers at each site, and also 2 high volume samplers here and here. And then the sites, oh, excuse me. I'm sorry. Excuse me, I'm sorry. So the sites here with the pentagons are the 6 sites that we collected soil samples from. And so we collected 10 centimeter cores from those 6 sample sites. We wanted to make sure we got a good spread of the the deposition plume that we modeled. So when we look at the results from our passive air samplers, we can see a consistent, we can see results consistent with our deposition plume model, or our pollution plume model. So the yellow dots are less concentrated of EPFRs, and then the purple dots have the higher concentration. So you can see that our sites to the southeast of the facility have the higher concentrations, and we even detected elevated levels at our site up to 9 miles away. Our concentration gradient is consistent with our smoke pollution model, and our highest concentration of EPFRs is actually here in the rock community. So the rock community is actually a very small community of majority older community members, and we can see that they are actually facing the most direct impact from the facility's practices. When we look at the soil samples, we actually observed radical presence on all the soil samples, which is again consistent to our air sampling results as well. we saw similar radical concentrations across the sampling set, which is again consistent with the community testimony and the emissions modeling. And our air sampling data showed the same radical activity across all of our samples. We found radical G values on the Colfax samples that were a little bit higher than what we measured on the East Palestine samples, which is important. I will talk a little bit more about the radical G values towards the end of the presentation. But it is important to notice that the Colfax samples were a little bit higher than the East Palestine samples when we look at the G values. So currently in Colfax, we are continuing our comprehensive air and soil monitoring. We have ongoing passive and active samplers in the field. We were actually just there last week doing a change out and doing some biological sampling collection. So we have our ongoing samplers, and we have also started collecting indoor dust sample to observe the presence of these toxicants inside community members' homes. And right now there are 2 manuscripts about our Colfax work that are currently being peer reviewed. We have one about our air monitoring results, along with a soil paper that is studying the impacts of these EPFRs on the soil microbiome. We have also initiated biological sampling with participating community members. We have collected urine and toenail samples to measure for elevated biomarkers and the presence of harmful heavy metals. We have detected elevated stress biomarkers and heavy metals such as lead detected in our early biological sampling data. And so when that, we just started processing the biological data, so I don't really have any of that to show, but our early indication is that we are going to see some elevated levels in these biological testing samples as well. So it's important when we do this community-facing research to share our work with, with the communities that we're working with. And so last summer, thanks to Darcy and the Swetland team, I was able to come to East Palestine and join in the data sharing event in East Palestine. This is a picture of me here. And we were able to do a great job of connecting with the community and sharing some of our research. And when we go to Colfax, we always make sure to have a community meeting when we're in town. We like to make sure we share our updated data and connect with the community to hear about any stories of facility operation, facility operation or anything like that, because it is really important to make sure that the community sees you when you are in town and make sure that they know that we're not just using them for data, that we actually are invested in how they're doing as well. So the environmental significance of this part of this part of the work is that both of these sampling sites identified the presence of these persistent toxicants, and these results indicate health risks that are associated with the combustion processes that are in these communities. The Colfax research has been able to be used to provide support to the community members, motivating policy changes regarding the facility practice. They were issued a new permit in December of 2023 that said they had to stop open burn operations and construct closed burn infrastructure. So they had to burn a closed burn facility in which to operate. They have been fighting that in court, but there were no reported burns in 2024. I do have an asterisk there because we went to Colfax in December of 2024 to conduct a routine change out of our monitors, and we heard several explosions coming from the facility that were consistent with their open detonation practices. And it is also worth noting that in June of 2024, Clean Harbors was the site of an explosion. A storage tank ignited on site and exploded, causing severe injuries to at least one worker. And we actually detected spikes on our monitors that day, indicating that the explosion was pretty significant. And then the East Palestine research is to be used as a starting point. So we have published this manuscript, and we hope to seek additional funding to do our our more widespread study of the evacuation area and the model deposition plume, so that we can identify the connection between these environmental toxicants and the open burn or the vented burn practices of the train derailment. And then now, as we close out the presentation, I'm just going to talk to you a little bit about how we are using these real-world samples to further the understanding around these combustion byproducts. So, as I mentioned earlier, previous studies have shown that our EPFRs can undergo radical recombination reactions. So I'm going to talk to you first about the recombination into dioxins and furans, and then I'm going to talk to you a little bit about EPFR cascade reactions into reactive oxygen species. So the resonance capabilities for EPFRs allow for multiple reaction possibilities. And here we've got two general reactions that show how these free radicals, these resonance stabled free radicals, can form our dioxins or furans. And so when we see these EPFRs, this actually could potentially pose a two-pronged threat, because EPFRs themselves are inherently dangerous via inhalation, but it seems that EPFRs in the environment can pose an additional threat by recombining into even more toxic dioxins or furans. So studies suggest that detection of EPFRs may be used as an initial indication of dioxins and furans. So what we did with our East Palestine study is we compared our EPFR concentrations and our dioxin concentrations using linear regression to see if we could determine some statistical correlation. And we found significant positive correlations for the toxic equivalency factor, or the toxic equivalency value, 5 dioxin furan congeners, and for the congener aggregates. So this suggests that there is a connection between EPFRs and the dioxin and furans that we were measuring as well. These correlations are among the first that have been observed on field collected soil samples, and these correlations provide field collected support to laboratory studies suggesting the connection between EPFRs and dioxins. Not only do they potentially share a generation source, but they could be co-generative, as EPFRs could recombine into form the dioxins and furans. And now let's talk a little bit about reactive oxygen species. So reactive oxygen species are oxygen-based free radicals that are extremely biologically reactive. So when they get into our body, they have very high reactivity, and they are directly attributed to oxidative stress-related illnesses. Research has found that EPFRs have instigated the cascade reaction that can result in the formation of these reactive oxygen species. So we have oxygen here interacting with our EPFRs, generating the reactive oxygen species cascade, ultimately forming our hydroxyl radical or our reactive oxygen species down here. Due to the high reactivity of reactive oxygen species, we can't do typical EPR measurements. We have to do a spin trapping experiment using DMPO, and I'll talk a little bit more about how that DMPO works. So it captures the hydroxyl radical, generating an observable radical complex that we can then measure on our EPR instrument. We know that the reactive oxygen species radical is different because it generates this 4-peak radical, which is much different than the multi-radical signal we observed for the soil sample. So here is our DMPO, and it interacts with our hydroxyl radical here, capturing it, forming our stable radical that we can then measure on our EPR. So we use simulated lung fluid when we do this spin trapping experiment, because this better mimics the biological conditions of the inhalation of these toxicants. We've done these reactive oxygen species tests in a number of buffer systems, but we found that doing it in the simulated lung fluid is the most biologically relevant. So that is what we do when we want to test how these real-world soils would react in our biological system. So I mentioned before that the G values of the Colfax soils were a little bit higher than the G values for the East Palestine soils. So we had in Colfax 2.0035 to 2.004. In East Palestine, we had lower at 2.0023 to 2.0034. So the 2.0023 values up to 2.0034, these are mainly carbon-centered radicals. When we get up to the higher, closer to 2.004, we start to get closer to oxygen-centered radicals. So previous work suggests that our oxygen-centered radicals are more reactive and thus more toxic than their carbon-centered counterparts. And we wanted to investigate this further, so we used our soils to carry out our spin trapping experiments in the simulated lung fluid to mimic the inhalation conditions of these contaminated soils. And then we normalized the concentrations of the generated hydroxyl radical to give us a direct comparison of the G value influence. So this is really important because when we generate these radicals in the lab, we're not able to really control what the G value is. We'll get very consistent G values when we generate them in the lab, but they're very strict. So we'll generate 2.0035 or 2.0040, but we won't be able to generate a full spread like we are able to observe with these real-world soils. And so this allows us to take a very, very interesting look at the effect of the G value on toxicity. So when we spread these out, the blue dots are the G values, and you can see it decreases from 2.004 here to 2.0023 here. So high to low. And we can see that the normalized hydroxyl radical production also decreases as we move from our oxygen centeredness over to where we get to our carbon centeredness. And as we get truly carbon centered in nature, we see our toxicity level off. So we used the normalization or the normalized values just so that we could compare each sample because we know the concentration values are wildly variable. But from this, we can see that a increase in G value into the oxygen-centered area coincides with an increase in toxicity. And another important thing we can see is when we look at the difference between the East Palestine samples and these ones over here are our Colfax samples. So we see our East Palestine samples having our more oxygen-centered G, or our more carbon-centered G value, excuse me, and most of these samples are seemingly less toxic than all of the Colfax samples. So this means that all of these sample sites need to be treated independently. We can't just go to East Palestine and collect the soils and say, oh, this has EPFRs, it's toxic, when we can see that the G value is actually more influential on the toxicity than the concentration might be. So this is just important to note that depending on the waste stream and the fuel source and the soil composition, we might have different toxicity effects in different locations, even though we're undergoing the similar combustion processes. So this has been very useful in helping to understand how the G value actually influences the toxicity of our EPFRs. So to conclude, we have noticed our elevated levels of EPFRs near the contamination source in both of our locations, which support our hypothesis that these combustion practices are generating these harmful toxicants, which can have direct impacts on the community. And we also detected these elevated levels of dioxins in East Palestine, suggesting that there is an ongoing risk to that community, that potential remediation needs to be looked into. We want to continue our additional research ongoing in Colfax and also our proposed study in East Palestine that needs to be conducted to comprehensively assess the risk factor or the risks that are facing our communities that we're studying. And we also were able to use this work to further the understanding of our combustion byproducts with their potential toxicity by correlating positively between the EPFRs and the dioxin furan concentrations, which, like I mentioned, are among the first to be seen with field collected soils. And we are also able to observe that G value spread across the wide range, giving us a more clear insight into the potential toxicity of these EPFRs. With that, I would like to acknowledge our community members, our community partners in East Palestine and Colfax, my advisors at LSU, Dr. Cook and Dr. Sprunger, my current advisor at NC State, Dr. Richmond Bryant, Dr. Kachitran and Dr. Duga, Dr. Cormier, very helpful members of the LSU Superfund, as well as the Superfund Research Group 5, and Dr. Chuchi, who has been very helpful in my postdoctoral at NC State. And with that, I will take any questions. Here is our manuscript in East Palestine, and as well as my personal LinkedIn. And with that, I'll take any questions. Thank you so much for your attention.
Thank you so much, Dr. Laird. We do have a few questions here in the chat. Looks like the first one, Shannon Connery had asked, how persistent are the pollutants in the body, the RR, are in per 30 years? So is there continuous exposure needed, or can short-term exposures result in health impacts?
So these regional screening levels are designed to reference values in the environment. These aren't biological levels. So these aren't how persistent they are in the body, but these are levels like if they're in the environment and you're exposed to that environment for 30 years, that's what the regional screening level indicates the risk of. So I don't know off the top of my head how persistent these dioxins and furans are inside the body, but I do know that they are persistent environmentally.
And it looks like Darcy had a question. How do you envision this work evolving given the current political environment?
So that's actually very interesting. With the current political environment, we are finding it a little bit difficult to think about or to talk about how we want to continue this research. It's not easy to find the right language to use right now because everything is just very intense right now. And we are doing work that we think is very important. And so it's important to continue the research, but we have to evolve. And we are still trying to figure out what that looks like.
Darcy also asked, do you engage workers in data collection for occupational health risks?
We don't currently do that, but I think that's a really important piece that we need to start to look at because I think occupational health risk is very important because people's jobs, you know, you shouldn't have to worry about getting sick from work. And so I think that we do need to focus a little bit more on occupational health risk when we do these kinds of studies.
Rebecca had shared, great work sharing your results out with the community. How are you including community members in your prospective studies?
So when we go to Colfax, we have a couple of very um, very connected community contacts that we like to reach out to, and when we connect with them, they are very good at getting the message out to other community members. And when we're doing research like this in Colfax with the community, they care and like they want to be involved because this facility has been directly impacting them for a lot of their lifetime. And they have all seen the negative impacts and they want to help stop it. So it's very easy to get community members involved because this is directly relevant to their lives and they want to help get this out of there.
And Dira had asked or said, I just saw veterans exposed to burn pits may receive compensation, wondered what they were.
I'm not sure about any compensation.
And then Tim Soshelski, did you want to come off mute and share your comments here? Tim had said, yeah, thank you for this excellent talk on a really important topic. So pleasure working with you and Jen and others on the fact sheets at East Palestine meeting. It's so critical that you collected independent samples in both locations. Related to Shannon's question, I know you didn't have time to talk about the biomarkers being collected, but are you able to control for urine concentration, i.e. urine creatinine or specific gravity? For some contaminants, this will be important. Happy to provide more details and talk more.
So thanks for this comment, Tim. But I gotta be honest with you, I am a chemist and not a biologist. So the urine collection and analysis is definitely someone else's department. I am mainly the soil guy, so I really don't know how to answer this question, but I do think that it would be great to hear some more. So we could definitely talk more about this.
There's another question in the Q&A. Tila had said sunflowers are often used in remediation efforts like in Chernobyl and lead pollution. Could planting sunflowers provide an aesthetic and practical community-centered solution to addressing soil pollution?
That's a really interesting statement because I'd never heard that. But something to note is across the street from the derailment site in East Palestine, where so when we were collecting the samples in East Palestine, during the time in which they collected the 6 samples in the restricted zone for us, they had me wait at a EPA staging area across the street from the derailment site. And at that staging area, they actually had a garden and it was full of sunflowers. So I don't know if they intentionally did that or anything like that, but that is something very interesting to think about. Um, so thanks for bringing that up.
Tim also asked, how did the folks at the EPA receive your work on EPFR given how new this approach is?
Um, I would say that initially they were open to hearing what we had to say. They didn't really get too interested in what we were talking about until we included the dioxin analysis into our reporting, which directly compares to their results. So like once we had data that was like directly comparable to their results, that's when they really started listening. They were, of course, open to us doing our sampling and testing, but they weren't putting a whole lot of stock into what we were presenting until we mixed in the dioxin results as well, which we didn't initially plan to do. We were initially just going to do the EPFR testing, but then we received some documentation from EPA about their dioxin testing that we weren't too too happy with. And so we decided to do dioxin testing of our own. And then once we did our dioxin testing and had some results, EPA was a little more inclined to listen to us.
I had a question for you, Myron.
Sure.
And just listening to this presentation, it's so interdisciplinary. You know, you said I'm a chemist, and then there's the biologist, there's the people that are working on, you know, whether it's occupational health, community, physical health, human health. How do you think your training in chemistry and also in your postdoc now has helped you work with all these different kinds of disciplinary perspectives, including community, to do the work that you're doing, you know, and be collaborative in that way?
I think I don't know that necessarily my training in chemistry has anything to do with it, but I do know that my graduate experience at LSU was very, very important in helping me to bridge between disciplines and figure out how to communicate between the community and make my science a little more digestible. And so I think that just getting exposure to working with community members, working with people in different disciplines, getting out of the lab is really important because a lot of times as a scientist, you find yourself in the lab for, months at a time and you don't talk to anyone else. And so I think it's really important that as scientists, we get out of the lab and we just interact with people who we wouldn't necessarily work with. And so I think the LSU Superfund was really, really pivotal in helping me develop my skills as a well-rounded scientist and also as a good communicator.
Awesome. That's really cool. And I think you're clearly a good communicator. I think that and you seem to value a lot of different perspectives. That's great. And Tila has a great suggestion for future research, collaboration research around testing the soil within the sunflower garden
Yeah.
and seeing how those samples are different or similar to the surrounding areas to see if there is a remediation effect.
Yeah. No, that's actually a really great idea.
We probably have time for one last question if anybody would like to close us out today or offer any feedback to Dr. Laird. Okay. Well, thank you.
Thank you.
And
Yes,
we'll be,
please, if you have any other questions, my email is also right here. If you have any questions that you didn't think of, please connect with me on LinkedIn or reach out. I would love to talk more about any of this stuff.
Yeah, I see a few people in the chat saying they are interested in connecting with you down the road. So hopefully, if you are interested, go ahead and directly email Dr. Laird, or we can let him know as well.
Thank you guys so much.
thank you. We'll be sending out the slides, the recording, the link to that, as well as Dr. Laird's contact information to everybody who registered and attended today. So thank you so much for your presentation, and everyone have a great day.
Thank you for having me.
Hey, take care. Bye.